So have you people done it?
Yes, sir.
Good. So is it possible that one of you can display your answers on screen? If you have that, if you have the copy, how have you done it? I think you have done it on paper. You have done it on paper.
Yes, sir.
Is it possible to show that paper? If possible. I mean, of course, I'm not insisting. Please don't feel that I'm insisting. Uh, I just want to see the level of your understanding. How much you've understood this one. It's okay. Is it possible? Is somebody attempting this? Is somebody attempting this? I mean, tell your response. Is it possible or not? If not possible, I will go ahead. No response. Why? Shall I point out someone? Babu, have you come today? Babu E or Babu V? Have you people come? Babu.
Yes, sir.
Okay. Have you solved the problems?
Yes, sir.
Is it possible to display your problem somehow?
Sir, ಗೊತ್ತಿಲ್ಲ sir ಹೆಂಗ್ ಮಾಡೋದು.
Okay, no problem. Okay, we'll go ahead. Fine. So this was the fissure projection I gave and asked you to convert into other 3 different projections. So how will we do this? Okay. So first, always you take the, and you know, Fisher's projection is the eclipsed projection, is it not? See, I am doing this live. So please follow carefully. And once I complete a projection, you can ask your questions. So till I complete, I hope that you can follow simply. You reserve your questions at the last. Fine. So how will you do this? You know, vertical line means the groups which are away from us, and these are the groups of the carbon skeleton, is it not? So we usually write a structure like this, is it not? Fine. Is it not? Okay. So this is the projection. Now you can convert this into Sawhorse and Newman very easily. So shall I do this? So if I do this, 1 second. Just take a look. Is the screen visible to you? To all of you?
Yes, sir.
Okay. See, I am using an application called.
Sir.
Yeah, 1 second. So I am using an application called ChemDraw. Okay. This is a very good application to draw the structures of organic compounds as well as to predict their spectra. Right? Okay. So let me convert this into Newman. Is it not? So converting into Newman is not that difficult, is it not? Because all that you should do is you write. Now, which is the front carbon now for me? Since I am looking the compound from here, I am visualizing the compound from this point. This one becomes my front carbon. So let me label that. Simply, I'll just put it as F. Okay. So it means our front carbon. Of course, on board, this is quite simple to do, but using applications, a bit difficult. And I will just write rare carbon for the carbon which is behind. Okay. See, please don't confuse this R to be the configuration R. Okay. Let me make it B. But it's possible that you may confuse it to R, configuration R. Back carbon. Okay. These are simply our notations to distinguish front and back carbon. You can also look at the molecule from here. Then this becomes your front carbon. Okay, since I am looking from here. See, any one, for example, me, I can't look from both ways, right? I have to choose one direction. So I am looking from here. So if I look from here, which is my front carbon is this one. Now you tell me which are the substituents on the front carbon? Tell me which are the substituents on the front carbon? Okay.
CH3.
One. Let me draw off the projection. Okay. So which are the substituents of, okay, fine. Which are the substituents of the front carbon?
HCl CH3.
Good. H. Which side does the H come? Towards your left, right?
Yes, sir.
Yeah, that is also important. The relative positions of the substituent is very important, right? Okay, this is your CH3. And where are your back carbon substituents? Where are your back carbon substituents?
In between.
Hello? Where are the substituents?
In between. In 60 degree distance
One sec. One.
in between the HCl.
Yeah, in between. They have to be in between because the molecule should assume a staggered conformation. But strictly, if you convert a fissure into Newman's, what is the conformation you are going to get?
Eclipsed Newman projection.
Very good. Yeah, eclipsed in Newman, eclipsed as well as in sawhorse. Eclipsed in wedge dash also. Later, we have to rotate the CC bond by 180 degree to convert that eclipsed into staggered. Is it not? Okay. So now, what is the simplest of the way? First, you write one sec. Let me expand this structure a bit. Okay. So let me expand these structures a bit. Are you people following this? Okay. So I'm just expanding this structure. Fine. So let me convert this first into the eclipsed conformation as it is from the fissures. Okay. Don't worry about those red things. What should come here now? Tell me. What is the substituent which should come here?
H, sir.
White, sir.
H, sir.
Okay. Who gave the answer OH? Who gave the answer? Someone gave the answer OH. Should not be OH, right?
Sorry, sir.
Should not be OH because this is the eclipsed conformation we are talking of. So in eclipsed, all the groups on the left side of the fissure eclipse each other, one another. And those on the right side eclipse one another. Is it not? And the top and the bottommost groups eclipse one another, each other. Is it not?
Yes, sir.
Okay. So what atom should come here? Which atom should come here? H. Is it not? And here?
OH.
OH. And here? Here.
COOH.
COOH. Is it not? So this is my compound, which, I mean, this is the converted projection. I have converted fissure into Newman. Yes, I have converted fissure into Newman. Yes, but as I told you, in the actual sense, in the real sense, the molecules always be in the staggered conformation. So what should I do now? I should rotate this.
Rotate the carbon atom by 180 degrees.
Yeah, not carbon atom. We should tell the carbon-carbon bond should be rotated. The atom cannot be rotated, right? The carbon-carbon bond should be rotated. The CC bond, the front carbon and the back carbon CC bond should be rotated and should get a staggered conformation. So how will I do that? Simply, you just have to take this. I'm just cutting and pasting this. Okay. So I will remove all these substituents here. Okay, fine. So now how will I do this? You just have to write bonds in between your carbon atoms. I mean, sorry, in between the substituents of the front carbon. Okay, now where are your, okay, what comes here? You tell me. What comes here?
CH3.
COH.
COOH.
OH, sir.
Not CH3. Why? Because CH3 is the substituent on the front carbon. Please don't change the positions of the substituents of the front carbon, because you're only rotating the back carbon, is it not? If you rotate both front and back carbon with the same angle, then basically you are simply rotating the whole molecule, is it not? You should not rotate whole molecule to change conformations. To change conformations, you have to rotate only one of the carbons attached to a CC bond, one of the carbons. So you are rotating only the back carbon by how many angle? By what angle? By 180 degree. So COOH comes up. OH, which is here, will come here. And here comes our H. Is it not? See, now this is the staggered conformation of the molecule. Now that is fine. But what is the what is the tip? What is that rapid way of doing this? While you rotate 180 degree, you simply put the opposite groups here. If I put a line here, which was there in the opposite side? COOH, bring it here. OH, bring it here. H, bring it here. Simple. Right? So even if you have not understood the concept of full rotations, projections fully, still you can attempt these questions correctly. How? By simply following the steps what I give. Like when you rotate 180 degree, when you want to convert eclipsed into staggered, put the lines in between the front carbon lines, and then the opposite groups put here. Simple. Okay. Now let us convert this into our sawhorse.
Newman.
This is what the Newman's projection is. Is there any confusion? This is the Newman's projection. Now I want to convert this into sawhorse. I can convert fissure directly into sawhorse also. Yes, fissure directly into sawhorse also. But since I have already made the fissures projection out of this, changing fissures into sawhorse is very easy compared to directly changing fissure into sawhorse. Is it not? Okay, let me do it both the ways. Let me convert the Newman's into sawhorse and let. So how will your sawhorse be? One second. Okay, I told you, just write a slant line and then put the groups. I've already made it into staggered, right? So I'll just convert directly into staggered. Oh my God. I have to expand this one sec. Okay. I saw horse. Okay. Which is our front carbon here. Front carbon is here. The substituents on the front carbon are H, Cl, CH3. Okay, fine. Now tell me the substituents here. What should come here?
COOH.
Good, COOH. Why? Because I told you in the staggered conformation, the opposite groups come in the anti-parallel direction in the sawhorse. Is it not? These are the groups in the anti-parallel orientation. The same anti-parallel orientation you should maintain here. Okay, now which is the group here? Tell me, which is the group here? There. Which is the group?
OH, sir.
OH, correct. OH. Why? Because you see, and of course it should be H. Is it not? So sawhorse projection of the given problem. Is it clear? Are there questions on how I converted Newman into Sawhorse?
No, sir.
No questions. Okay. So how will you do for direct conversion of fissure into Sawhorse? You just have to write a conformation like this. Write the eclipsed conformation, right? Okay. What is the group here?
CO.
Good, COH, because those are the substituents which are eclipsing each other. And the group here, H and H are eclipsing, right? Writing an eclipsed conformation is easy. Just write those on the left side, on the left side. Just write those on the right side, on the right side. It should be H here, is it not? And what is here? OH. Okay, fine. So this is the eclipsed conformation. So fissure is now converted to eclipsed. Eclipsed, you can convert into staggered by rotating this CC bond 180 degrees Celsius, not Celsius, 180 degrees. Any questions now? Any questions now?
No, sir.
Okay. Shall we do it for the I'm going to just rub all these things. Take up the wedge dash, the last one.
Yes.
Wedge dash. So in the wedge dash, always remember, you should put your carbon skeleton on the plane lines. Is it not simple lines? Put your carbon skeleton on the simple line. Is it not? So which are the substituents now on the carbon skeleton? CH3 and COOH. So now every atom, just put sorry, put it like this. Okay, don't worry about the length of the bonds now, because those have to be fine. Now, okay, which one should come here? You tell me. Now this is the front carbon, so I will label this as F, and this is the back carbon. Okay. Anyways, front and back is when we are converting fissure into Newmans, but when we are converting fissure into wedge dash, you're seeing the molecule from here, right? You're seeing the molecule from here and putting these groups on the plane of paper. These groups on the plane of paper. So that is what I have done. CH3, C, COOH. You are seeing the molecule from here. If you are seeing the molecule from this point and bringing the groups on the plane of paper, the carbon skeleton, which are the groups towards you? You are here. Which are the groups towards you?
OHCl.
Very good. OH and Cl. So OH and Cl have to be represented on
Wedge.
wedge. Very good. Yeah, very good. They have to be represented on solid wedge. So this is OH, right? I mean, don't put OH here. Then you are changing the structure of the molecule altogether. Anyway, you may not confuse putting OH and Cl because the other group COOH is there, right? OH is attached to the carbon, which is attached to COOH. So it is not possible. Even with the highest level of confusion, don't put a OH here. Then you are changing the molecule's structure altogether. You'll go into some other isomer, isomers. Okay, but anyway, you won't confuse, I am sure, because the carbon should be attached to same groups. This carbon is attached to OH, COH, OH, COH, OH, OH. And now H and H. Is it not? So simply, this is the wedge dash representation of the given molecule, which is in the Fisher's representation. But you can stop at this stage, no problem, because as I told you, in your exams at least, when you get questions, you can stop at this stage. This is even the wedge dash representation of a molecule. There is no problem. But what is the problem with this structure? What is the problem with this structure? Tell me. In terms of conformation, this is still an eclipsed conformation, right? What you have written. Is it not? Is it
Yes,
not?
sir.
Okay. So what should you do now?
Staggered convert model.
Yes. ಹೇಗ್ ಮಾಡೋದು?
Staggered convert ಮಾಡ್ಬೇಕು.
Yes. How do you convert this into staggered? Huh? You just have to rotate this bond by 180 degrees. Is it not? You simply rotate this bond by 180 degrees. So if you rotate that bond by 180 degree, what do you get? The carbon skeleton will become zigzag now, basically. The carbon skeleton will become zigzag. Okay, fine. Now tell me, since I have rotated this, you are essentially rotating only the carbon here. The back carbon you are rotating. So the groups become twisted. Let me write the carbon skeleton first. So which is what's the carbon skeleton? COH. CH3, is it not? Okay. Now, the groups on the carbon you have not rotated, don't change their positions. So you have to keep them like the same thing. Look at this. I have not changed the orientation of the groups. The one which was facing me is still facing me. The one which was away from me is still away from me. Only the carbon which you have rotated change their orientations. So where do you get your groups now? So if you have a wedge there and a dash here, okay, which is the group which should come on the wedge? Don't put OH now, because after rotation, yes, after rotation, the OH would have gone that side, the other side, is it not? So this is the correct representation of the molecule. In fact, I can refine this structure a bit, because this doesn't seem to be a better structure. I can refine the structure a bit. Okay, fine, no problem. Anyways, this is too complicated. Is it not? This is too complicated. You draw it in a better way, yeah, that's it. Yeah, okay. This is better, I feel. So what is this projection? This is nothing but the wedge dash projection. But since the carbon skeleton is oriented in a zigzag manner, this becomes a zigzag conformation. Zigzag conformation of the molecule. So even when you write a lengthy carbon chain, you should write like this. You cannot write it like you have one bond here, bond. Okay, you cannot write it like this, right? Bond and going down. You should not write. And again, what will happen? The other bond will go down. The other bond will go down. The other bond will go down. So if you go on writing eclipsed in eclipsed manner for a lengthy chain, essentially you end up meeting the ends of the chain. If there is a substituent on one end, the other on the other. If there is A here and B here, if there is A here and B here, finally they are going to overlap on each other. So this is not the correct representation. So always you should write the carbon skeleton in the zigzag manner. Did you understand this? Did you people understand this?
Yes, sir.
Yes, sir.
So we will do one more problem. Convert a wedge.
Sir, one doubt ಇದೆ.
ಹೇಳಪ್ಪ. Okay, fine. Okay, yes.
ಸರ್ ಇದು ಫಿಶರ್ ಪ್ರೊಜೆಕ್ಷನ್ ಅಲ್ಲಿ
Uh-huh.
ಸರ್ ಎಚ್ ಇದೆಯಲ್ಲ ಸರ್ ಒಂದೇ ಕಡೆ ಅಲ್ಲಿಂದನೂ ನೋಡಲ್ಲ ಸರ್ ವ್ಯತ್ಯಾಸ ಕನ್ವರ್ಟ್ ಮಾಡ್ಬೇಕಾದ್ರೆ.
ನೋಡ್ಬೋದು. Yeah, you can do that also. You can do that, no problem. You can do
ಓಕೆ
that.
ಸರ್.
But okay, anyway, your question is
ನಾನು ಅದೇ ತರ ಕನ್ವರ್ಟ್ ಮಾಡಿದ್ದೆ
ಮಾಡಿರಿ.
ಎಸ್
Then you will get equivalent configurations. Fine. But why I did not look from, why I chose not to look from here? Usually what we do is we choose an end for our visualization which has more substituents, not more hydrogens.
ಓಕೆ ಸರ್.
Then it will be easier to do.
ಓಕೆ ಸರ್.
Okay. So it is always that the hydrogens we represent always away from us. The substituents we keep towards us.
ಓಕೆ ಸರ್.
Although from configuration point of view, this doesn't make any difference. But this is the usual notion in writing stereochemical structures. Why? Because when I discuss R&S configuration with you people, you will see that to assign R&S configuration, the molecule's least priority group should be kept away from you. So invariably in all molecules, if there is a H on chiral center, H will be the one of least priority. So that should be away from you. Do you understand this?
ಎಸ್ ಸರ್.
Okay. So always try to keep H away from you, always. Try to keep H. Now, for example, in this structure, if I want to assign R&S configuration, it will be easier because my least priority group is already away from us. Are you understanding this?
ಎಸ್ ಸರ್.
Okay, okay. So try to visualize the molecule from this side. It is not compulsory. I am not telling it you should strictly stick to visualizing the molecule from this side. No problem. But as I told you in my previous classes, only with experience of dealing with stereochemistry, you will get all these tricks. Fine. Anyway, at this stage, your question is very good. Why don't I look at the molecule from this side? You can look molecule from that side also. Okay, can I proceed to the next problem if there are no more questions?
ಎಸ್ ಸರ್.
Okay.
ಎಸ್ ಸರ್.
Fine. Yeah, this was the molecule which I gave. Yeah, fine. I hope that you have attempted solving this question also. Fine. Now let me convert this into the fissure first. Fissure, easier. Fissure. Once you get into fissure, writing Newmans and Sawhorse become easier. You convert this into the fissure. So if you want to convert this into the fissure, how to do that? Your carbon skeleton is kept. One second. I just write off the fissures projection and then later we'll write the substituents. Fine. So let me make this as my front carbon. Fine. Is it okay? Is it okay?
ಎಸ್ ಸರ್.
Okay, fine. It's not just okay. That has to be made front carbon. There is no other way.
Yes.
Why? Because what is the notion in the, what is the convention while writing the fissures projection? The highest oxidized carbon should be always on the top, right? The highest oxidized carbon of the skeleton should be on the top. And you look at this carbon, this is only the alkyl carbon. Does it contain any attachment like OH, Cl, such things? No. Now, C2H5 and CH2Cl, which carbon is more oxidized?
C2H.
C2HCl, yes. A carbon which is attached to halogen is also oxidized carbon. Okay. You can go back to and refer to the formal oxidation states notes if you have. Carbon which is attached to halogen atom is equivalent to carbon attached to oxygen atom in terms of oxidation. Okay. So carbon attached to Cl is the highest oxidized one. So you just write this here on the top and C2H5 here. Okay. No problem. Fine. Okay. Now, since I am visualizing the molecule from here, please remember, I am visualizing the molecule from here. So, and CH2 is away from me. This whole carbon skeleton is also away from me, because these are the skeleton, these are the substituents on the plane, which have on the plane means carbon skeleton substituents. Carbon skeleton substituent should go away from you in the Fisher's projection, is it not? So you have to visualize the molecule from here. OH comes where? Tell me now. You are visualizing the molecule from here. Here.
Right
It
side,
should come on
sir.
this- yes, it should come on the right side. Correct. Very good. And Br naturally here. Now you tell me. As I told you, this is a zigzag representation already. Zigzag representation means it is a staggered representation of the molecule. Staggered representation. But Fisher's projection is an eclipsed representation. So you should rotate this 180 degree, get the substituents to the eclipsed positions, and then write the Fisher's projection of that eclipsed conformation. So I can do one more step. I can write one more structure, rotating this 180 degree and writing it. No problem. I can do that. That is like going stepwise. But you know, when you are doing this problem and you want to solve it really fast, then every additional step writing you should avoid. All those steps you should write down in your mind. Okay, you should mentally visualize those steps. So how should I write now? Tell me.
Right
It comes
side
here.
OH.
You rotate
Left
this.
side.
You
The
rotate
right
this.
side Cl.
You rotate this and then write the conformation.
Right side Cl, left side OH.
Right side Cl.
Cl,
Okay.
left side OH.
Left side OH. Correct. Is it not?
Yes, sir.
You have any questions? You want more clarifications on this? See, you're visualizing the molecule from here, right? When you are visualizing the molecule from here, these two substituents are away from you basically. But you rotate this, and then what happens? Bring those substituents towards you. When you rotate this, bring the substituents towards you. So OH comes here, Cl comes here. Is it not? So OH will be towards your right, like Br, like Br. OH will be towards your right, and Cl will be towards your left. You can write one more if you want. Okay, anyways. So let me do that. See, I'll tell you. If you want, you can write one more to avoid confusions. At least now, to avoid confusions. You are making it eclipsed now, so it won't go up. It comes here, CH to Cl. CH to Cl comes here. So if the CH to Cl has come here, where will your OH be? Okay, so let me write off the wedge and dash. Okay, OH, you see the, oh, sorry. OH will come here and
Dash it.
your Cl will come here. Is it? Will come here. So it's like now you have converted the zigzag conformation, staggered conformation into eclipsed in the wedge dash itself. In the wedge dash, you have done eclipsed conformation. Now the eclipsed has to be converted to fissure easily, because converting an eclipsed conformation to fissure is easy. You look at this, skeleton is on the vertical line, carbon skeleton, and now you are looking from here. The OH is on your left, Br is here. And which are the groups on one side of the plane? OH and Cl. So OH and Cl are on the right side of the plane, both of them. Which are the groups on the other side of the plane? Br and OH, which have come here, Br and OH. So are there questions on this? Are there questions on this? Huh? See, the best way of understanding these things, you work with models. You work with models. Okay, fine. But where to get models now? You can just make models with the materials you get in your households. You simply take your sticks, maybe even broomsticks, and tie threads. And just, I think these are all simple high schoolish projects here. What I am telling, ball and stick models of molecules. You can do that. Fine. So you now send your names in the chat box for the attendance sake. And you have any questions, please go ahead, ask. Did you people understand here? Did you people understand?
Yes, sir.
Okay.
Sir.
Fine.
Sir.
Yeah. So the thing which you have understood and how to make it more concrete in your minds, that should practice more and more problems on interconversions. Only then your understanding would become better and better. See, it is easier now when somebody is explaining this to get a feeling that you have understood everything. But when you are doing it independently, solo, single-handed, with nobody to help you, then the difficulties you start facing. Therefore, how to get really prepared for those things is by working out more and more problems. In fact, you have plenty of problems on internet. You can just keep solving them. Even there are workbooks available to solve stereochemistry problems. Workbooks on stereochemistry problems. So you can use those workbooks and do. Okay, fine. So if there are no more questions, shall I end the class? Shall I end the class? If there are no more questions.
Yes, sir.
Yes, sir.
Okay, fine. So next class onwards, we will start with optical isomers.
ಸರ್ ಎಲ್ಲ ಎಪ್ಲಿಟ್ಸ್ಡ್ ಆದ್ಮೇಲೆ ಸ್ಟ್ಯಾಗರ್ಡ್ ಕನ್ವರ್ಟ್ ಮಾಡ್ಬೇಕಾ ಸರ್?
ಈಗ ಅರ್ಲಿ ಸ್ಟೇಜಸ್ ಅಲ್ವಾ ನೀವು ಮಾಡ್ತಾ ಇರೋದು, ಒಳ್ಳೇದು ಹಂಗ್ ಮಾಡಿದಾಗ. ಓಕೆ
ಸರ್ ಡೈರೆಕ್ಟ್ ಸ್ಟ್ಯಾಗರ್ಡ್ ಮಾಡಿದ್ರೆ ರಾಂಗ್ ಆಗುತ್ತೆ ಸರ್?
ಆಗಲ್ಲ, ಡೆಫಿನೆಟ್ಲಿ ಆಗಲ್ಲ. ಬಟ್ ಡೈರೆಕ್ಟ್ ಆಗಿ ಸ್ಟ್ಯಾಗರ್ಡ್ ಮಾಡೋದು ಬೆಸ್ಟ್. ಆದ್ರೆ ಅದು ನಿಮ್ಗೆ ಪ್ರಾಕ್ಟೀಸ್ ಇಲ್ಲ ಅಂದ್ರೆ ಮಿಸ್ ಆಗೋ ಚಾನ್ಸ್ ಇರುತ್ತೆ. ಅದಕ್ಕೆ ಫಸ್ಟ್ ಎಕ್ಲಿಪ್ಸ್ ಮಾಡಿ ಸ್ಟ್ಯಾಗರ್ಡ್ ಮಾಡಿ ಅಂದಿದ್ದು. ಒಂದು 10 ಪ್ರಾಬ್ಲಮ್ಸ್ ಈ ತರ ಮಾಡಿದಾಗ ನಿಮ್ಗೆ ಆಟೋಮೆಟಿಕಲಿ ಒಂದು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡಿಂಗ್ ಬಂದ್ಬಿಟ್ಟಿರುತ್ತೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಹೆಂಗ್ ಕನ್ವರ್ಟ್ ಮಾಡೋದು ಅಂತ ಅಷ್ಟೇ. See, this is my first problem I am solving, wedge dash to fissure. If I were solving the 10th problem, I would have definitely done like that. Directly from fissure to directly from staggered to eclipse, I would have done it. Okay, this is only the initial stage. That's best. That is when you are doing the steps mentally, I told you, right? So in stereochemistry, we should go to a level of understanding where we can do the steps mentally. That is best. You do it very good. I appreciate that very much. But to avoid confusion at the early stage now, I'm just doing in this way. I'm just adding one more confirmation there, eclipse confirmation, and then converting it to standard. Okay. Any more questions? Any more questions? Who asked this question? Can I know your name?
Sir, Varshini.
Varshini. Okay, fine.